The next phase of dealing with errors is exception handling. So we do have to have a good grasp of exception hierarchies from the standpoint of we need to know what to handle. We need to know how our data is modeled. But past that, the way we handle it is pretty much common across the different types of exceptions. The semantics for dealing with that is very much similar. So when an exception happens, it generally means everything stops. The end of the world as we know it. So in this flow, I go to the grocery store, I load up my shopping cart, I get a bunch of stuff inside of there, I go up to the register, they put everything on the slider, they slide it over, they get it all, put it up in bags, I swipe my card, boom, there's no money. So what happens at that point? There's no point to continue. They're not going to let me bag up my groceries and walk out at that point. Unless there's some way for me to give them cash, it hadn't happened. I mean, I remember the first time I ever went to shop at an Aldi's. Swipe my card. Well, wait, that's a credit card. They only take, I think at that time, they only took cash or check. They didn't even take debit cards back then. So there was no way for me to pay for my groceries. So literally, I had to take my groceries and put them to the side and then run to the bank and get some cash and come back and get them. So that completely blew my flow inside of there. So I couldn't continue. The same thing is true in software. If you can't meet all the conditions of executing the software, then there's no reason to continue executing that software, and the program will end. The program will terminate. So one important factor inside of dealing with exceptions is this idea of a block in Java. A Java block is a unit of execution delineated by curly brackets. So every method is a block. Every if statement is a block. Every switch statement is a block. Every loop is a block. And then we'll see in a second, we're going to create blocks within exception handlers. So inside of a block, if an exception occurs, the rest of the execution of that block is terminated. So think of it this way. If you're off reading a book and you're on chapter 7 and it's an ebook, and you're 10 pages into chapter 7, and you lose power on your ebook, well, in Java's terms, you'd have to start over from the beginning of chapter 7. That's where it would pick up again. That's the concept we're talking about of the block. So if you have these lines of code in the block, doesn't matter if you're halfway through them, doesn't matter if you're all the way at the end, they're all wiped out from the execution of the block. Now, understanding that flow will help us understand the execution of exceptions and how they work. I want to remind you about a block, and again, the important thing about blocks is the curly brackets that come into play. So that exception then, as we said, kills the block, and so when we find a method like this, and we find a line of code that could cause an exception, now normally where exceptions will come up is by doing some method call. It could happen, as I said, any little thing. I could do a multiplication, division, subtraction, whatever. But mostly what we're going to deal with here is method calls. So I have a method call that could throw an exception. And so when I go off and run this code, if nothing goes wrong, it says I started my work and I'm done with my work. It prints out all those lines. If an exception happens here, it will print out starting work because it already did that code. But then anything that happens after it, done with work, does not happen. If there was one line or 500 lines that happen after that, where the exception happens, all further work stops. That block is toast. Now, we don't want that. We don't want that to happen, so we want to deal with stopping errors. We want to stop the errors from stopping the rest of the progress we made. So if I go to the grocery store, and I take all that time to load up on my cart, and I go to the checkout, and I take all that time to put the stuff on the cart, and I go out and swipe my card and something goes wrong, well, I want an exception handler to make sure I can at least continue my transaction there. That's my watchdog, if you will, up in the corner there. That's going to help that. So if I'm broke, well, maybe my option is I can pick up a broom and start cleaning. It's the good old days where everybody always needed help on the side, so I can work off my groceries and get my work done. So it's not super practical today. Normally what I'd either have is cash in my pocket or a second card or write a check or something like that. But the point is, if the first thing fails, I can try something else. And the way we do that in Java is through exception handlers. So there's a little lingo I want to make sure that you're catching on. So when I say an exception is thrown, that's very intentional. We're going to see that syntax inside of there. But there's other terms that are sometimes used in literature and by the people. So you can say I can raise an exception or admit an exception. That's something that would happen when you call a method. A method could throw an exception, raise an exception, admit an exception. And then the flip side of that is I can catch an exception, but sometimes you can also say I can handle an exception or I can trap an exception. You might hear those terms used out there, but in Java we'll hear about try catch, but we also talk about exception handlers. But that means there's the source of an exception, then there's the response to the exception, and that's where the try and the catch comes into the Java part of it, as we're going to see here in a second. So the caller, the method that gets called could raise or trap or throw an exception. Raise or throw an exception. The handler handles or traps the exception. So the person who called it is the one who's doing that work inside of there. So, as we said, Java exception handlers has the syntax called try catch. The try part is saying, here's some lines of code which could cause a problem. We're going to give it a try. The catch part is saying, if there's a problem, I'm the guy to go and see. And so the code we just saw before, when we want to call that method that could throw an exception, really long method name there, we can put that inside of a try catch within its own block. You see the open curly brackets and close curly brackets. And at the end of that block, we throw the word catch inside of there, which says if an exception happens, then do this work that we said is going to be out there. So the unsafe stuff goes in between the initial curly brackets of the try statement, and then the response to something bad happen goes between the curly brackets of the catch statement. And in this case, we print out an error line, something bad happened. That might be the best we can do in this case. The response is going to be based off of what went wrong, what you were trying to do, what you can do. We'll talk about that later on, but the mechanics of it is that simple. Here's the lines of code I want to try. If it works, great. If not, if something bad happens, then we go over here and this is what we do instead. It's kind of like if, and then the error goes here, else you just kind of keep going. The catch statement is completely ignored if no errors happen. So the idea is to limit the impact of the risk. Whatever lines that are risky, that are optional, if you will, that happen, I put inside of my try catch. The things that have to happen, either which way, go outside of it. So if we actually have to say we're done with the work at the end, we arrange our code like this. So even if an exception happens, it will say starting work, something bad happened, done with work. But we'll know that we finished our work at the end of this flow. Now, an important distinction here, you want to remember that at the end of the day, a block is always a new set of scope. So any variables I declare inside of my try block don't exist outside of that try block. And it's true of if statements, it's true of switches, it's true of loops, it's true of methods. When we declare something inside of curly brackets, any block, it lives only within that. So the net of that is in the try catch statement, whatever I do in the first block is also visible in the second block. It's a little exception to the rule. If you do something in an if statement, whatever's in the if block is not visible to what's in the else block. That doesn't work like that. But it does for try-catch statements. So you can see, in this case, I have some data I'm reading from the file. I get data from the file. If there's an error with that data, and it returns something back, if the error was getting the data, then it wouldn't have happened. But I can still see this file data right there. So if an error happened later in the code, I could still see the file data. Now, the problem is I cannot see it at the end. So if I tried to say the length of this file, even if everything works successfully, the variable doesn't exist here. That line of code would not compile. It would not work. And so the way around that, quite simply, is I declare the variable outside of my block. So I have my file data here with no initialization. The problem that could be here is I have to initialize it either in the try block or the catch block. If it doesn't get initialized in both, then it will have a compiler error down below saying this could possibly have been not initialized. But I could always just say int 0 up top. Again, it's up to you to create your logic. The idea that something went wrong could be the fact that the file data is null or something like that. So you could always initialize it to null and have a check after it went if file data is equal to null. If your logic demands file data is at least a size 0 array, you could do that in the exception block down here. So there's a bunch of different ways to design this stuff. It doesn't write your code for you, but it does give you options on how you go about writing your code. Just remembering that it is a block and it functions with all the rules of being a block within variable scope. Now the last pit I want to point out there, you may or may not have seen this before, but instead of system.out.println, here I did system.error.println. And that's a special flow. So instead of going to the outflow, it goes to the error flow. Mostly it still goes to the user, mostly goes in the same way. Most of the cool IDEs, Eclipse and NetBeans and such, will print it out to the user, but then turn it red or something like that. So the error reference lets us know that this is something that it doesn't normally print out. If you have different flows, if system.out goes to a file and system.error goes to a different file, it won't show up in the outflow. It'll only show up in the error flow. But for the most part, it goes in front of the user sees it, and they all go to the same place. It just depends on how your Java system is configured. But just wanted to point that out as one little trick here. All right, well, that's the basics of exception handling. There's much more we can see from that, but take a moment and play with these basics, this basic syntax, before we jump into the really complicated, powerful stuff we can do with exceptions.